How's it going, everyone? So I wanted to give you another update on this NFT-Magic project I've been working on, where basically you can upload a zip and it will mint and generate a bunch of NFTs for you automatically on the Polygon network. So I wanted to give you a overview of what I'm currently planning to build out next, and then probably share some code along the way as I'm doing that. So the last video I showed you how I built a system for basically uploading a zip file, and that'll take that zip file and generate a bunch of NFT images using different layers, right? I need a way to basically take that zip file and mint all the NFTs, right? So if you create 10,000 NFTs, you want to be able to allow the user to mint all those on the Polygon network, right? So in order to do that, there's a couple things that have to happen, right? So I've been looking into using IPFS, which I might make some more videos in the future kind of explaining what IPFS is. But for the most part, this is the actual system that I'm building out to be able to mint these things on the fly. So let me just walk you through the flow. I plan to basically have a API hosted on a Mono Lambda on Amazon, right? So a Mono Lambda is basically, you take a bunch of API endpoints, you put them in a single Lambda, and you put that in front of an API gateway. That allows you to basically hit via a REST URL to your APIs, and that'll invoke some Lambda. So I plan to have one endpoint where a user can create what we call a pre-signed URL. So the idea is after they generate that zip file that has all those NFTs, they can go through and they can modify any type of metadata that they might want. They can delete whatever NFTs they might want, rename some files. But ultimately, when they're ready, they can take that zip and they should be able to upload it to S3, right? So in order to do that, I want to keep the S3 bucket private, and I want to make sure that I'm kind of rate limiting who and how often people can upload zip files to the bucket, right? So I want to make an API endpoint to get what we call a pre-signed URL, which is basically like a short-lived permission to say you have the permission to upload a file that's a certain size to this bucket, and it expires in an hour or something, right? So the first step of this entire process of minting that zip file is we want the user to be able to upload that file to an S3 bucket. So they hit the pre-signed URL, they get a URL, and then they have permission to upload to the S3 bucket. Now, I haven't really thought about how the user can pay me money, because minting these NFTs does cost money. So I need to figure out some way to allow them to use their Web3 or MetaMask wallet to maybe add some funds to a contract, and then I can use those funds to basically mint their NFTs for them. I haven't really figured that all out. I just want to get the basics of all this stuff laid out first and kind of implement a prototype. But what I plan to do is once they upload a file to that S3 bucket, what we can do is we can create what we call an S3 trigger, which is going to basically invoke a Lambda to kind of consume and run over that zip file here. So let me make sure I'm not blocking it with my head. But whenever they actually upload that file to the S3 bucket, it's going to invoke a Lambda, which is going to unzip that file. And then for every entry in that file, it's going to basically do the following things. It's going to upload the image. So step 4, it's going to upload the image to IPFS, right? So IPFS is a node or like a service you can run on a machine. You can run on your desktop. You can run on a DigitalOcean VM. But basically, it's a way that you can add files, and then it'll basically run a hash sum over the file contents and give you back a unique identifier. And you can later use that unique identifier to query an IPFS gateway to get back the actual file itself. So this is good for NFTs because now in the NFT metadata, you can put a URL to an IPFS hash. And now anyone who wants to look at your NFT, they know what the hash is and they can get that file from anywhere in the system, right? Anywhere in the IPFS ecosystem, I guess you could say, or the node pool. I don't know what they call it behind the scenes. I'm still kind of learning a lot of these terminologies, but so what I had to do is on my DigitalOcean droplet, I had to create a small little API, which basically allows you to do a post request. And kind of similar to the other API, it's using Multer to accept a file, and a user can upload any type of file to this API. And what this API does is it kind of stores that file that's been uploaded to a directory, and then it tells the IPFS node that's running on that same machine to basically add it to its cluster, or add it to its node or file system. I don't know what the real terms are, but after I've added the file, I get back a hash, and I need to send that back to this Lambda over here, because we need to take that hash and put it in the metadata file that's coming in step 5. All right, so step 5 is we update the metadata, and we put that IPFS hash for the image inside the metadata, so that when we create the NFT, we actually know where we can look at the actual NFT image. So after we've done that, step 6 is you upload the metadata, right? The metadata is good to go. It's describing the NFT. Everything should be good. And we also want to upload that metadata to IPFS as well. So same process, hit the API Express endpoint, and then we basically do an IPFS space add, and then the file that'll add it to the node so that anyone in the future can discover that based on the hash. And then step 7 is we want to keep track of all these metadata URLs, right? So when we actually mint these NFTs, we need to know what the metadata IPFS hash is so that we can tell the contract, hey, this is where you can fetch the NFT metadata, right? So step 7 is kind of keep track of that. And I'm kind of debating where the step 8 should be. So step 8 is you actually need a NFT contract, like an ECR 721 contract deployed somewhere so that you can actually start minting things on that contract. So I don't know where this happens. Maybe this could be like the first step, but basically I want to basically deploy a contract using Solidity. I do have some code written up over here. If I look over here, I can go to contracts, and I do have some stuff kind of set up. I'll explain all this in maybe a future video, but I have a contract called NFT-Magic, which basically extends a NFT token metadata. This is all like from open source libraries that I found. But basically what you're saying is when I deploy this contract, I'm saying give this NFT contract a couple of variables. I want to give it an owner, a name, and a symbol. So that's what's happening on line 8 here. We deployed the new contract, and then we want to kind of, for each file or for each metadata that we got in line 7, we want to mint a new NFT. So basically using that contract when it's been deployed, you can call the mint function on it. So this is what we mean when we say mint an NFT. Basically, there's an actual function on the contract that says mint, and you basically tell it what address you want this NFT to belong to, which NFT unique ID should belong to this address, and then also the URI. Again, the URI, this is going to be that IPFS metadata hash URL. Okay, so this is so like other, I don't know, NFT platforms like OpenSea can actually know where to grab that metadata and then figure out what image it needs to show and the UI for you, okay? So most of the stuff related to IPFS in this API, I actually have set up. Like if I go over here, I have the contract set up, I have this IPFS folder set up, and inside of this, I have this Express app, which basically has one endpoint. And what this endpoint does is it takes a file, writes it to the file system, and then it kind of adds that to IPFS. I don't know if there's a better way to do this. I'm still learning about IPFS, but it seems like in order to actually add things to your node, it has to be a command that's ran from your node. You can't do it remotely. I could be wrong about that, but I also don't want to open this node up for everyone to just start adding and pinning things to it, because then I might run out of disk space because I only have like 2 gigabytes of disk space on this node. So I have that all kind of prototyped and implemented in. I also have this contract stuff set up. I've been working with a lot of random stuff just to be able to make sure that I can deploy the contract. So again, I have this NFT-Magic contract set up that basically sets up a ECR 721 contract. And then I have a bunch of random like scripts that verified that I could deploy it and kind of mint on it, right? So I have a mint.js script, which is basically calling the contract that I deployed to the Polygon network, and I'm able to mint some random images to it. So if I go over to OpenSea, okay, so I have on OpenSea, I have like this random collection that I added. It's really easy to add a collection to OpenSea. You basically just go to your collections, you click add, and you say import from an existing contract. But I have all these random images, which are just screenshots of like my code editors that I've been kind of uploading. And these have all been created using this mint function here. So I might kind of explain this in another video. It's too much for this video. I'm just want to give an overview. But again, what I'm trying to show you is that I kind of been prototyping all these different little boxes. Except for this one, I haven't really done this work yet. But I want to kind of think a little bit longer about like, what is the most performant way to mint 10,000 NFTs and not have the user have to wait for like 5 hours? Because that's one issue that you run into right now if you want to mint your own collection, especially a large collection, is that you have to sit around waiting a long time for all these files to be added to IPFS, for your metadata to be added to IPFS, and then you have to wait for your contract to get deployed, and then you have to wait for your contract to mint all of these metadata files, which can kind of add up, right? So I think on most of these networks, you can only run like one transaction at a time. Like they have to be processed concurrently as the nonce kind of increments. So I don't know if there's a way to kind of make these run as fast as possible. I kind of need to do more investigation on that and see if there's a way to like really quickly mint all these NFTs, or if I need to kind of mint one and then wait until it's done, mint another, wait till it's done. And if that's the case, what I need to do is probably bring in like an SQS queue and have another service that's kind of processing these kind of one by one not concurrently, but in sequence, right? We don't want to mint 10 NFTs at a time because you have to wait for the first one to finish before you can move on to the next one. So that's what I'm trying to kind of work out in my head. And also, how is the payment system going to work? Like, that needs to come in at some point. So another thing I'm trying to figure out in my head is like, how is the payment system going to work? Like, I want to be able to have someone just kind of send money to a contract, and when the contract gets the money, it's going to emit a Solidity event. And then basically, I don't know if like my API or something in Amazon is just listening for those events, and when they do fire, that's when this whole thing will fire off. But again, I just want to prototype something first, and then I'm going to come back and refine it. So hopefully you guys are interested in seeing that. If you like watching this video, give me a thumbs up. Also, leave me a comment below if you have any comments or suggestions or feedback on how I can kind of build upon this system or build upon this project. And like always, if you're new to this project, be sure to click the subscribe button and that bell icon to get more notifications on my videos. Because I'm going to be publishing other videos like this in the future that should hopefully help you learn more about Web3 and become a better web developer. All right, thanks for watching. Have a good day.